Hello, my name is Alex Hagensanke and I would like to use this talk to give an update on the small maths grant, a Bayesian approach to complex land use change modeling, where I am the principal investigator and I'm working along co-investigators Dr. Sue Hughes and Dr. Naratib Santiti Sadikwa. The postdoctoral researcher on the project is Dr. Jingyang Yu. In our project, we are concerned with the future growth of urban areas and the consequences this has for the rural-urban interface and peri-urban areas. We do this using a spatial dynamic model of urban growth dynamics. The main innovation in this project was the use of a Bayesian technique of parameter estimation called approximate Bayesian computation. One interesting challenge that we encountered was that over our period of data availability, only limited urban growth took place. And this provided us with too little information to reliably estimate our models. We ended up reconsidering the typical procedure used in our field of estimating models over a short period of past data, and we ended up extending the calibration period all the way back to a completely non-urban starting point. Thus, we were training our models not on recent change, but on the ability to grow in our virtual computer lab realistic urban settlement patterns from scratch. And this worked surprisingly well, and it allowed us to realistically simulate future urban development of existing towns while accounting for model and parameter uncertainty. At another level, the Landscape Decisions program challenged us in explaining why our model is meaningful to decision makers, and especially those that are concerned with the natural environment. The model is not prescriptive, it doesn't make particular recommendations to decision makers or solve any problem. Instead, it provides a range of possible outcomes of future urbanization trajectories. Why would that be relevant? It's important here to recognize the context. In the UK, there currently is strong political will for more housing development. Plans are to go to over 300,000 new homes per year, and increasingly this building takes place on previously undeveloped land. Furthermore, UK planning laws are increasingly liberal. Even the 25-year Environment Plan embodies the desire to remove barriers to new housing development through offsetting mechanisms. Planning decisions, in the meanwhile, are being made at the administrative level of local authorities, of which there are 343 in England alone, providing a highly fragmented management. And we see the value of our models in being able to inform decision makers at this level of looking beyond the spatial and temporal scope of particular planning problems and to see the cumulative impact that local decisions have on shaping the urban-rural interface. The wide range of outcomes that are possible indicate the need for a long-term strategy. Thus, our models are in the not-so-common position of providing insight in the decision space, making clear what actually is possible within the decisions that decision makers can make. And this is quite different from more common approaches of analyzing impacts of decisions or optimizing decision problems. Now, our project is officially over, and the main output is now very close to publication. However, we are continuing our research in this area. We are expanding the analysis to a global data set of urban settlement patterns. And also, we are really enjoying the engagement within the Landscape Decisions program and jostling with other participants across disciplines about the complex web of skills, interdependencies, perspectives that make landscape dynamics so interesting.